So the first way that calculus is applied to longboarding is in finding the area of the deck, or the wooden part, the structure of the board. If you look at it, it looks like what could be 2 parabolas or 4 quadratics. And to find the area, I think the easiest way is to use quadratics. So each quadrant has its own curve or equation. In order to find the total area, you have to find the area underneath each individual curve and add them all together. You can see this in the drawing, which is also a graph. It's supposed to be the bird's eye view of the deck. And the width divides the board into 2 sections that are unequal. There's the longer tail part on the left, and then there's the shorter front part on the right. And then the length divides the board symmetrical, like the top and the bottom, above and below the x-axis. So to find the equation, I marked the center of the board lengthwise, and then I would measure from the center out towards the edge, and found several lengths from the center to the edge that were 2 inches apart on the x-axis. Plugged them into the calculator and then found the equation. The equation for quadrant 1 ended up being negative 0.021x squared plus 0.147x plus 4.085, and then for quadrant 4, which was just basically the negative of that equation, I just switched the signs for everything. And for quadrant 2, the equation was y equals negative 0.006x squared minus 0.021x plus 4.433, and then once again, the equation for the curve underneath was just the opposite. The area under each curve is shown on the drawing. When you add them all together, the total area of the deck of the board is 289.866 inches squared. The height of the trucks, or the metal things that hold the wheels to the board, is 3.7 inches, and the width is 6.7 between each wheels, but that's not important because you're just trying to find the height, so you can multiply that times the area to find the volume. And so when you multiply them together, you get 1072.504 inches cubed, which is the total area underneath the board of the A. Many people who longboard sometimes will go down hills, big hills or small hills, and calculus can also be used in finding the velocity of a longboarder when going down a hill. So I made up a random hill. I made up coordinates and plotted them on a graph, and connected them with what would be probably an accurate hill-looking line. So the points are 10, 50, 30, 26, and 55. And then to find the equation of the hill, I plotted those points in a calculator and then found what would be the equation if they were connected. And the equation would be y equals 0.003x2 minus 1.35x plus 63.125. You can find the velocity at each of the 3 points that I have marked on the hill. And to find instantaneous velocity, you have to take the derivative of the equation of the hill. When you do that, the velocity equation is 0.006x minus 1.35 meters per second. And to find the velocity at each point, you plug in the x value, which would be either 10, 30, or 50. So at the first point, the velocity is negative 1.29. The second point, the velocity is negative 1.17. And the third point, or the one closest to the bottom, the velocity is negative 1.05. These are all in meters per second, and they're negative because you're going downhill.